So this is very similar to a problem that was on the previous worksheet. I wanted to give you more practice with it. We know the distance between 2 points, but we do not know the x-coordinate of one of the points. So we want to know what are the values of x that make this point here exactly 17 units away from this point. And algebra allows us to arrive at the answer with certainty, which is nice, as opposed to getting out a ruler and graphing these points on a coordinate plane and figuring out what value of x will make this point exactly 17 away from this one. So the distance formula, d equals the square root of the quantity x2 minus x1 all squared plus the quantity y2 minus y1, that squared. It doesn't matter if it's x1 minus x2, you're squaring it. It's going to come out to be positive regardless. So I know my distance, it's 17. And I know one of the x's, it's 5. I don't know the other one, so I'll leave that as a variable. I know both the y's, -4 minus 11. Now, as I was going around, there were a lot of people who had misconceptions about how to handle squares and square roots. So I'll try to address those. Those are common. You're not alone. In this case, you cannot remove the squares just because there's a square root over it. The reason is because you have multiple terms here. Terms are things in math that are separated by plus or minus signs. So this is one term, this is a separate term. So unfortunately, square roots don't work that way. I understand why people think that, likely because they're told at some point in their life that the square root of x squared is x. But the square root of x squared plus y squared is not x plus y. And you don't need to believe anything I say. It's the beauty of mathematics. Everything can be proven. Here's how you prove it. Make x equal a number. Make y equal a number, another number. Plug them in. What's 2 squared? What's 3 squared? What's 4 plus 9? Is the square root of 13 5? No. So that is proof that this, if I put an equal sign, would not be true. Okay? So keep that in mind. You do not need to FOIL this or expand this binomial. If you want to, fine. I just don't think it's the most efficient way of doing it. What I would do next is get rid of the square root by squaring both sides. That eliminates that big radical, because squaring is the inverse of square rooting. 17 squared, I saw in several people's papers, it's 289. The radical goes away. You're left with the quantity 5 minus x squared, and then -4 minus 11 is -15. That gets squared. Now I want to get this square by itself so I can square root it. So at this stage I'm at 289 equals the quantity 5 minus x squared plus 225, because that's -15 times itself. And then I could subtract 225. And that leaves me with 64 equals the quantity 5 minus x squared. Now I square root. Just keep in mind to add a plus or minus to one side. So this square root can eradicate this square. They dissolve each other. And you're left with positive or -8 is equivalent to 5 minus x. So we're almost done. You can think of this as two equations. 8 equals 5 minus x, and -8 equals 5 minus x. So when you solve this, you get 3 equals negative x, or x equals negative 3, and negative 13 equals negative x, or x equals positive 13. So those are the two values of x, such that this point will be exactly 17 units away from this point. And you could prove that by plotting them on graph paper. Any questions on the first one? Great. Second one, we'll do it in the same way. 4 equals the square root of, you can do x minus negative 2 squared plus negative 5 minus 0 squared. 4 equals the square root of x plus 2 all squared plus negative 5 squared. 4 equals the square root of the quantity x plus 2 squared plus 25. Say again?
Isn't it negative 2 minus x? Or does that not?
It does not matter. Yep. And then I will square both sides. So I get 16 equals the quantity x plus 2 squared plus 25. I then subtract 25. And I get negative 9 equals the quantity x plus 2 squared. The only way that you can square a number and get a negative is if this is imaginary. But you can go ahead and try to square root. So if you want to be technically accurate, it's plus or minus 3i. I is the imaginary number. It's the square root of negative 1. But we don't plot I on the Cartesian coordinate plane. The x and the y have to be real numbers, not imaginary numbers. So what's implied here is that there is no solution. And I encourage you to think about multiple ways of thinking about a problem. For example, if you were to do this graphically, you've got negative 2 comma 0, which is on which axis? Thank you. It's on the x-axis. And then x comma negative 5 is some point that lies on the horizontal line y equals negative 5. Think about it. What is the shortest possible distance from negative 2, 0 and this line? 5. Hopefully you see that. This is 5 units. But I only gave you 4 units to work with. So you can't even reach that line with a straight down arrow. Okay? Any questions there? Good.